Hello everybody, this is the timer. I have two timers actually here, two clocks, one at 100 Hertz. Actually it should be at 100 Hertz, but to be completely honest, I am not sure. I'm not completely sure. I have no device to measure the frequency. I have a frequency meter. I mounted it, I tried to measure with it, and it just crap itself. It didn't give me, it gave me like 3 values for the frequency. It was jumping between 3 values and I couldn't seriously get the frequency of that. So I'm guessing that I'm having a 100 Hertz. If it's too low or too high, I will change it. I will change that capacitor that you see there, that yellow little thing there. This is the second oscillator. That is the oscillator that will increment everything. It's internal oscillator for this board. So right now I'm powering with 5 volts, as you can see there. But this display is working with 3 volts. These chips should deliver 3 volts alternatively to that display. So I have my meter here, and I hope I can do everything with one hand and show you. Let me. So far I built this board module that I'm having here, and now I'm preparing to build this module. Nothing is there. You see, it's I'm only placing the chips to see how everything is going. So back to the measurement. I hope I can do it effectively with one hand. Okay, so here is negative, and here is 5 volts, 5.02, as you can see. And on the other side here is 2.8. 2.8. So this LED that you are seeing, that you are barely seeing there, I hope you can see it flashing there. Let me make some dark. That LED is working at 3 volts. So I'm powering with 5 volts, but everything else is powered with 3 volts. If I'm changing from 5 volts to 12 volts, it will still deliver 3 volts to the rest of the chip. This chip IMS, this is a voltage regulator IMS 1117, 311117. This is the name of the voltage regulator that I'm using here, and he works up to 15 volts. So 12 volts is perfectly fine. So that's what I wanted to say, and that's a frequency that I can see the pulsing of the chip. But let's do it. You see, let's change the frequency, and it will change. It's very fast, extremely fast there, and it's working. What I'm saying is working. So I have, unfortunately, when I'm getting to the margin of the potentiometer, is not doing anything. It's kind of cutting off. But after a while, it will start doing. I have to. It's a margin of nothingness there. But then it's starting to do. Probably is the 5 volts. Is the 3 volts. It's lower voltage. That's why. Probably that's why it's working like a little bit funky. But yeah, if I need, actually, I was thinking on exactly 1 second. Exactly 1 second beat pulse. So I have 6. I have 6 gates in this chip, in this 7414 chip. You can probably see there. There. So I have 6 gates, and I can use another gate at discretion and make a special 1 second, perfectly 1 second. I have no idea how to make it perfectly, but it is an idea. This variable frequency that I can run the entire clock, the entire device pretty much. But I want to have the option to put exactly perfectly 1 second and a switch for it. Probably I will have to enlarge this board to add something else somewhere else, there or there probably. I have some spaces there and there. I didn't design this board here that I'm having. I didn't design it very well, to be completely sincere. But I was thinking, in my defense, I was thinking as a user interface, because I have most of the buttons are here on this board. I have this potentiometer, those 2 buttons, and that's it. Probably and the reset button I will have to add here as well, I think, if I remember right. I probably forget that one to add, but I will have to add it later. So yeah, this is it. This is me preparing. This is the LCD with its I don't know how they are called, port. And I will have to. And if you didn't know already, this is cardboard. This very simple cardboard from a chocolate. It even has some stuff there. Doesn't matter. And that's how I'm building everything on cardboard. And holy fuck! Wait until I will have to drag the wire. That's the hardest part, wiring everything. This is another XOR gate. These guys are XOR gates here. 4030, like in my 3D 4030, and that is also XOR gate. Yeah, this is it for this part. I built yesterday. Actually, 2 days it took me. I was lazy, and it took me 2 days to build this board. And this is the 3rd day when I'm laying out this LCD driver. Pretty much, this will be the LCD and the driver for it. I hope everything will be fine. We'll see. No phenomenal progress so far, but I wanted to show you the markings that I made for the chips here, just to be sure they are equally, laid down, positioned. And I did it without calculating. I did it by eye, just putting them, all these chips, in a line and moving them left and right until it was, good enough. And then I marked their positions and made all these lines. It might be a tiny little bit of distance error between them. I expect that, but pretty much is there. I hope I didn't make any great mistakes. Let me actually position them exactly perfectly. Come on. And see if they are fitting good enough, if it's good enough. They should be there. Okay. I'm only interested in the space between them. Here, in the space between them, on the left and right side. like I said, I did it exactly like you're seeing here, by eye, and just mark there and then move them out, and I made the lines, and that's it. These little guys, I will not make the lines for them, because for the position, it's too much to draw for each. Probably I'll make 1 or 2 lines, general position. All right, this is a little bit of more progress. I'm laying down the pads, and only 2 pads per each chip, like that, you see? And perfect. This guy should be down a little bit, because I have 4 gates here and 3 there. But for the rest of this tree, I have 4, 4, 4 and 3, 3, 3. And these 3 little guys that I will put underneath will be linked here, where it's more convenient to drag the wire than the opposite side. Logic, no? Right, that's why I invest a little bit this. I put the smaller ones on top, because the numbering is weird of the LCD numbers, pins. Yeah, that's it. This is it for this part. Alright, so I will film while I'm making these pads. I already cut a little bit of this material that I'm having there. These are from light bulbs, and I smashed them and make them, they were round, and I made them flat. And this is it, and I will put them there as pads. Also for the LCD as well, for this slot. And also for the chips, the pads. This is my other phone. I have 2 phones, 2 smartphones, but this is a bit more. I don't like it. It's kind of good, but it's discharging very, very fast. The battery is probably dying or something, and it's heating up extremely fast. And don't like warm devices in my hand, of course. But I use this device here. Usually, I'm having this image on this mobile phone that I'm filming with right now. I'm more used to it. But this guy, I put it here just to film how I'm usually working. I'm not using this particular mobile phone that I'm having right now here, but like I said, I'm using this guy that I'm filming with. But this is the way I'm doing my stuff. You know, I should print everything on a paper probably. But it's an interesting. I have the colors. And I have the zoom on this. It's quite interesting to work like this. I'm not used to it. This is a novelty for me to work like this with a mobile phone and displaying like that. It's a bit of battery is losing battery life. But I think I a bit fast, but maybe I can find the solution for that. Okay, enough with my setup that I'm having here. So I will, like I said, I have a. Let me try this to actually charge it, because I have that guy for an older version, and maybe this you see this thing that I made it to work. Maybe it will work on this other. It might have the same port. It looks like, maybe. Yeah. It says it blipped, but it doesn't show me anything that it's actually doing. Yeah. Let's hope it is charging in the same time while I'm watching it. I'll check it from time to time, but you know it's there. Okay, all right. I hope I will not lose that. Actually, you know what? I will put it back just to be sure. So 7486, 1 single gate. All right. Nice. Let me put it back. Okay, like that. And now let's build it. So, like that. Now, fucking hell. So right now I'm picking the dimension of it. 2 from 1, I believe. And this very good. 2, 3, 3. Nah, I have a lot of this. Okay. Yeah. And like that. So far, the 3, probably. Okay. So I prepared these pads for these guys here, and for the chips. And now, okay. Good enough. Let's see. Yeah, good. Good. Yeah. So will be wider. That is no problem. The problem is that I will have to measure them every time. Okay. This is a little bit hard to bend. Too hard. Okay, so I have only 5 to change shots. So I have 4 3, but I will use 2, just to undo them here. I'll do them because yeah, they can be. I will secure most of them pretty much. And let's hope I have the right dimension here. That's one. Okay. All right, now I'll have to prepare them. And that is one. I hope you can see what I'm doing here, or at least to see the result, how it's looking. And let's see if I'm lucky to fit exactly perfectly here, and it looks like it is. That's good enough. Come on. Like that. That is number 1. And this is number 2. Okay. Let me hammer it. Just to flatten it a little bit, you know. Here, it was a bit too thick, and I wanted to flatten it better. Excellent, good, I like it. Oh, I like it! Now the next ones. Okay. This is extra long, a little bit too long. Okay. And like I said, this I will glue down. Okay. Probably this way, yeah. Yeah. Okay, this way. I made it a little bit longer for that longer pad they have. Okay. Right. A little bit more here. Oh, motherfucker. Okay. Yeah, it's good. I think, yeah, I bent a little bit too hard, this needle, and it was broken. It was starting to get broken. I remember now. I made it like an L, like that, and now when I press it a little bit too hard, it's not, because it was already broken when I tried to bend it. Yeah. But now on camera, yeah, now live. Okay. It's good like that as well, but it's a bit, yeah, it's good. It's good. I made a little bit longer this one here, because like that. Yeah, I need a longer needle, a little bit longer than this. I'm used with the longer, a little bit longer one. Yeah, that's good. Shit broke, you know, shit broke. And let's go here. Alright. This is quite hard to bend. Right. Flatten it. Okay. Okay, and here I will glue it. Wait. With my super glue. This silicone glue. That is one. And that is two. Alright. Yeah, I have to clean it up on this side. Okay. Come on. Very good. That is one. That is two. Okay. It's looking good. It's looking very good. Very, very good. Yeah, the cardboard is a bit flimsy, but I will make it harder with some other cardboards on the back, probably. Huh, I should have think of that. I didn't. Okay. Yeah, now this guy is here and here. So these are for the chips, for the ICs, like that. And two of them on diagonal are good enough. The rest of the pins will be wired directly on the pin. And that's how stuff will work. Yeah, well, probably it's good enough what you've seen so far. You will see when I will actually mount the chip there. And see you later. Alright, I already put this 4, and now I have this 4, and this board is finished from the pad point of view, placing the pads, but not yet finished because I have to make them and to assemble them. So I will film while how I'm making it, how I'm making them, and it should be good enough. Yeah. I remelted the plastic on my needle here. Here is the little the other piece from, I hope you can see it shining there. It's a little bit of piece of metal inside. I know it's not very good, very visible. Yeah, here it is. That's it. That's it. And it was another piece of, I tried to bend it, but this is very stiff steel, and if you try to bend it, it will crack. I knew it, but I tried anyway. I managed actually to bend it a little bit like this, and from the straight position, from straight like this, a little bit like this. But I tried more than this. I tried to make it like an L shape, and this L shape just cracked, and I feel it cracked. It was still holding, then I quickly poured the plastic around it, and I hope it will hold. But it cracked right now when I was filming here, and yeah, now it's remelted. Everything is back to normal, and that's the story with the needle. Do not try to bend or to bend too hard. Sewing needle. This is actually a needle used for sewing. It's yeah, and it's getting shorter and shorter. The reason why I bend it was because being straight, like it is, like this one is, pressing on the plastic many times, it poke through the plastic on this other side, and I had to remelt everything. So that's why I decided to bend it a little bit. And that small bend like that, it wasn't good enough. It also poke with that bending as well. That's why I decided to bend it 90 degrees, like an L shape, and it cracked. And that's why it cracked. And now it is straight, but and I know it will come out from this other side if I'm pushing too hard. But if I'm doing this with the paper, I probably poke something else much more harder, like leather or something. I don't remember, or rubber. Probably I did in the past, and it's way up until it got out from the other side. So that's I know the problem is not resolved. I hope I can find a solution for that needle to make it not poke, not move inside, you know. Okay. So now I will have to bend everything that I have here with respect to this size, and I'll bend it on the shape there, on the exact size. I'm usually not doing it like this, like I'm doing it right now. But for this, it's working. For this margin, the margin one. Usually I'm bending them and measuring and fitting them somehow. You know, that's the usual procedure. But this time, I find a way to cheat it a little bit to let's say, to make it faster. Nothing is faster. Nothing is fast. It's very slow motion and consistent. You know, slow and consistent, and don't give up. That's the name of the game. Okay. That's the other one that I made it already. The first one. And voila. And voila. Everything is good. By bending them like this, they get very, very strong. Well, not very, very, but strong enough to hold, to hold from dragging, especially for this display, for this holder when I'm dragging. But this holder is very, you see, it's extremely loose. It is making contact. I hope it's making good contact. This holder is not made for these pins. These pins are too thin. This holder holes are made for thicker pins. Let me show you which ones. This thicker pins, like this, you see? Like this, here. They are a bit more thick. And when you press it, you can feel it going down a bit more harder. But those pins from the LCD are a bit thinner, and it's making contact. But yeah, it's making contact. That's all all I have to worry about. If not, it is not making contact, I'm screwed if it's not making contact correctly. But I think it is. I can bend it around. Come on, there it is. So that's why I'm making these pads with ears and bend the ears for better strength from dragging, from pulling it off. But it will not be the case of pulling it off. This is a tiny bit smaller. Yeah, I have to somehow press it there. Okay. All right. Okay. That one was a bit smaller, tiny bit smaller, but we make it fit. This one also, probably the cardboard was. Yeah, it's better to be smaller than longer, to eat a little bit more from the cardboard here. I can press it like that and fit extremely well actually. This way, when it's a tiny little bit smaller, it's good. When it's longer than this dimension, it's not good. It's wobbly, it's moving around, it's not secure, and I have to remake it. But voila. Pretty cool. I don't like that it's flimsy like this. Probably I'll have to add a stronger cardboard here on the back, but probably on all of them I will put a stronger cardboard in the end. So these are the pads for the LCD, and these are the pads for the ICs on one board. Pretty much this is it for this part. Alright, I believe it's good, and I don't really need that. It's good to film while I'm gluing, while I'm soldering this holder here. Because this LCD will be removed from the holder, but I need the holders with its pins to make the connections from the ICs to the pins. So now I will solder its pins. I hope I will not make mistakes. You know what? I will solder these guys on the bottom first, and I will deal with the top ones in the end. Okay, yeah. That is one. That is good. And I will not listen to my advice, because this is actually a welding procedure, what I'm doing right now. When I was welding something, to be sure that I'm fitting it perfectly, I'm welding 2 points. So this is soldering right now, but welding with a stick weld. It's exactly what I did here. I did it with a stick welder, and it is positioned quite well, quite good. And that pin there, I didn't prepare these pins at all. I should have, but they catch the solder quite well. It's good enough. And also my iron tip is mosting with solder. It's having a good amount of solder on it. So yeah. These pads here in the middle are for reinforcing. These pads on the sides, also for reinforcing. But for strengthening. That's why I didn't add for each pin, because I'm not crazy. A pad for each pin, it should have been like that, but I'm using a shortcut here. It's a shortcut method, I guess. So I'm adding a little bit more solder where I see that is not enough, where I feel is not enough. Yeah, it's good. It's good. It is good. I'm resoldering a little bit, just to be sure. Okay, so this is it, and now I can very easily, come on, get out. Probably they are squished like that. I don't want to force because the cardboard is not really a good. I cannot get it easily out now. It did catch a little bit there. It is in force, a little tiny bit of force. I believe this guy is here is having a. But this is it. These are the. Well, now I'll have to add the chips somehow there and deal with this height here. I need this. Da? Fac film. Intrași tu pe film aici. Intrași tu voi să tați film.
Bine. La revedere.
Închide ușa. Lasă ușa. Și vezi că ai buzunar deschis acolo. Să nu-ți zboare. Unde e pe calea, la grădină? La grădină?
Da, văd la luminită.
Da. So, Da, du-l tu. Ia-l acum, că zbori afară. Ia pungile alea de gunoi măcar. Care le aruncați și mers mai departe. Right. Okay, so like I said, I have to deal with this height. I hope I can be able to deal with this height of this holder. The thing is that I have to link wires from the pins of this chip to the pins of this holder here. So I need them there. And if they will be, I can get them all out if it will be too much problem. If it's okay, if I can deal with them working like this, good for me. If they will create more problems than they should, I can remove them and use another method then. I know it's not a good thing to mount them like this from the beginning, from the start. I will see how. Yeah, well, I will mount on video the chips as well, because why not? No? So like that. There it is. I hope it's on the line there. It's aligned. Yeah, good enough, I guess. It's not perfectly aligned, but I can make it perfect. Now it's perfect. I have some markings here, barely visible. This tiny, I don't think the camera can see them, but there are some vertical lines, and they are good, very good for centering everything. I'm also looking on the mark of the chip to point this way, because that's the proper way of mounting it. Alright. Yeah, I suppose it is possible to work like this, I hope. But I will not say yet that it is good or bad, because when I will have to add the wires, then it will be the real test of how everything is mounted here, of these holders, if they are impeding or not. Okay, a little bit. Okay, this is looking good so far, but remember, I have to add those SMD components as well somewhere there. Most probably I'll have to take this out. Both of them, probably. Most probably I'll have to take them out and put some holes and drag the wires to the holes and then link them to these pins. Probably I made a big mistake putting them first right now. I will see when I will build the first group and when I will wire everything. I'll have to think about it, because this is kind of a prototype. These are the parts that I glued, and they are moving when I'm heating them up like I am right now. But if they are cooling down, they are good. The problem is on this board that I'm making here, the biggest problem is how to reach with my hot iron here. So that's why I leave plenty of spaces between the chips, because I will have to intervene with wires and then with the iron inside there. That's why I leave a ton of space. That's why it is so spacey. But it will not be that spacey, because I will have to add those little 3 gates at the bottom of them. So far it's looking good. Correct? It's looking very good so far. And this driver will be commanded from the third module board that will come in the future. But I like it. I also have plenty of space here between the chip and the LCD. By the way, you will see how easy this is fitting inside here. At least it was for when it wasn't catched here. But now it's kind of having a little bit, saving plenty of space here. Plenty of space. It's looking interesting. Bye-bye. Okay, I will not push it, because it's kind of grabbing, which is good. It's a good thing when it's grabbing. Alright. I hope you like it. See you next time. Alright, so I took out these holders for the LCD, because I cannot work. I will have to find something else, another method of dealing with those pins that are outside and to link them somehow. I will figure it out. But until then, I will have to add more components, these little buggers, these little gates, and I only have these two to put them. I'm not sure how well. Can you see this here? Yeah, I'm having it here, how the position should be, with the 2 legs towards right and the 3 legs towards left. So that's how the component is. You see, the 2 legs in that direction and the 3 legs in that direction. And thanks God, it's having 5 and distinctive legs. If they were 6 legs, shit. You know, 3 on. So this is how I'm doing it. I'm using glue for shoes. This is very, very strong and very good glue. It's very rubbery. It's like a rubber. And this is how I'm doing. I'm putting on the back. I want to say a drop, but it's more like, I don't know, something. Only a drop is not. Yeah, it's like a blob. It's a blob. Okay, good enough. And now, so this is my first. Actually, for this one, it was liquid. It was exactly like a drop. But for this other one, is not exactly as a drop. So I'm pressing it down. And voila, that's it. This is the mounting. How easy it is to mount the SMD component by gluing it. It's very, very easy. And the only thing that I have to take care of and to be careful is the position. I have to close it very quickly because it's getting hard very quickly. So this, yeah, it is a bit too rubbery. All right, I'm trying to squeeze something from here, but it's very, very sticky. If it's something there, it's very sticky. Yeah, probably now. Okay, so the position, the only problem is the position. Now, when I'm positioning it, especially these first ones that I'm having here. And I have to have a good distance between them. This way I want it a little bit here, to be in the center of everything. Now I'm squishing on this guy as well. And I'm leaving considerable space between them because I will have to drag wires from all those pins that you can see there. Holy fuck, holy fuck. This will be something. The wiring for these guys will be something. Alright, so, okay, I have the components there, so that is good. Holy fucking shit. Alright, and I will probably add all of them. Now, go away. This for this, and another 3 for this. 1, 2, and 3, and this is it. 12 of them. So this way I kind of balanced how many 4 gates in one chip and how many 1 gate per chip. You know, I kind of balanced them. And also I'm testing them in the same time. It's a big test, and if it will not work, I will be very, very screwed because it is a ton of work. If it will not, if some stupid errors will appear because of this. So I'm kind of risking. I didn't test them at all. I'm just blindly, yeah, this is a drop, very nice drop here, liquid drop. So I didn't test them because I'm trusting them absolutely, and I should have tested them, but I tested the other chips, the 4 gates 74, what's his name, 86. So the 7486 dip package, I test them and they are fine. But these little guys, I never test them, and I hope, but I kind of trust them like that. Let's see, I took considerable amount here, but it's disappeared. So this is, I have to quickly close this because it will get hard very quickly, and I don't really want hard glue in my bottle. I need liquid glue in my bottle. Yeah, kind of. Yeah, it's a blob there again. Pretty much. Okay, that's the second, or the first, or whatever. This is a good drop here. Not drop, drop. It's a liquid drop. It's a very good one. Now I'm looking for the spacing and the lining in the same time to be okay. Yeah, like you are seeing, I am doing it by eye. I'm not calculating anything. It's not that critical what I'm doing right now. I'm just mounting some components, pretty much. That's all I'm doing. And hopefully they will not fly from here while I'm doing all the other stuff. No, they will hold in position, hopefully, because they're quite tiny. And I do trust my glue that I have here, but you know, it's glue on plastic, and being glue on plastic, it's not a very, the adherence is not good enough. It's a general rule. So this one in the middle here. And I can feel I'm squishing quite a big blob, and quite hard blob of glue underneath this component. And it is, I can see it squished out from between these two pins. Now I'm pressing them a little bit. How cool is this? Huh? And imagine how much work I will have to do for the wiring. Holy fucking shit. But if I'm putting something in plan to do, I am doing it. No question about it. No questions asked. Let's see the others. And this guy here on the margin. So they are rotated inverse, with the 2 here and the 3 here. Okay, that's what I wanted to check. And it's good that I did check. Like this. So it's completely inversed from those guys. So I have to be careful with the pins of these chips to point in the right direction. And so far so good. I hope I didn't make any mistakes. Alright, so far so good. I hope you like it. I hope you like my distribution of integrated circuits. So now they are all placed. Oh yeah, which is very good. Which is very, very good. And next, the easy part, wiring. And here in the picture, actually, it's only the outputs, not the inputs. As you can see, the inputs are not managed. I didn't make the wiring for the inputs, only the outputs, because I have to connect them to the to these rails for the connectors. And this is all that you are seeing here. The next stage, when I'll have to add the inputs, that will be another story. Now I can see something that I missed. Well, I already made the board, but the next step, the next wiring, is to add the clock on the inputs here. This brown wire here also here and here, but they are linked together to this pad here. Everything is linked together. This is a brown wire for each of them, is the same clock, and it should go from one to another, like that. And also to the little guys as well. Holy fucking shit. Yeah, I will see how I will manage this. This is because of these little guys. These little guys are posing a little bit of problem. I hope I can make it with them. I really hope so. With these little guys. I hope they are not too little for my wiring. I really hope so. Yeah, they look quite stable there. I'm not pushing them too hard. I'm only checking them slightly. All right, that's it. See you next time when I will actually put some wires probably. So I managed to put the power wires. Let me show you. So the positive and negative wires pretty much. The positive from here to there is one single wire. Well, multiple pieces of wire. You see here, zack, zack, zack. And the negative from here to here, there and there, and it's here on the bottom, this line. And I only prepared, you know, if you can see, you see those holes, those little holes there, for these little gates, and I color coded red for positive, blue for negative, and from these power rails that I'm having here, this one and the other one, I have to drag to all of these gates the power, the power rail, and then I'll have to think about the logic wiring. So the power wiring is the first thing to do, and after I finish the power wiring to add to all this board, to all the components on it, I will put another cardboard to protect everything and to strengthen it in the same time, and then I will start to add the logic wires that are going to the pins of the LCD. Shit fuck. It's a shit fuck of work. It's a shit ton of work. Yeah, this is how it's looking so far. All right. Thank you very much. See you later. All right, I finished adding all the power wires, the positive and the negative, to all these motherfuckers. And look how it is looking on the back. And yeah, pretty wild. Yeah, I'm very happy that I finished this part. It was very hard. It was hard. And at some point, I was thinking I cannot do it, but because they are so little. And I'm not very sure about the strength of the soldering. But yeah, you see. Oh, it says there 86 74 86 it means. So this guy, in my opinion, they are soldered good enough. And this 3 pins side was a little bit funky, was a little bit yeah, you see, zoomed in and everything. All right, yeah, I'm very happy that I finished putting the power rails. Next is the easy part, adding the output wires. And I draw this. All the drawings that you are seeing here, all these lines, are only the outputs, not the inputs. The inputs are next, after I will make the outputs. I will see. We will see. Thank you very much. To the progress on this board, I've added another cardboard here, and the power lines, the positive and the negative, are underneath this cardboard. But this cardboard is protecting those lines from outside interference. And this line that you are seeing here is a single line, as you can see if you follow it, but it's connecting 2 by 2 pins. And here it is on is this brown wire, you see here, and each brown wire, I didn't make a connection between them and between this, but it is a single line that is connecting everything. You see, it's coming from here, from that, and it's connecting to that pin, 40 pin, and this is the clock, 100 hertz for the chip, and it needs to be compared here inside this chip. So for each gate, it means 2 pins. So 2 pins here. It's this pin and that pin. Let me show you with something more pointy. So it's this pin, the last pin, and this pin here, not this. This is the negative. So immediately near it is this. In the middle here are the outputs. The outputs for this gate, for the bottom gate, is this, and the input is this and this, 2 inputs. And for this is the output. Yes, this is the output for this stop gate here, and this is input. So one input for this gate is linked to that 100 hertz clock, and also on this other side as well. So not this first one, this is the positive rail, as you can see the red mark there, but immediately next to it, this second pin here, and this last pin is also. And the gate is moved a little bit down because of that top pin, and this is output and output, and 2 inputs for this gate here, and this is the output B for this gate here with 2 inputs. Pretty much that's it. This is the configuration. This is how it's made, this 4030 XOR gate, and that's what I did. Now I didn't link, so for now I linked all these gates between them, all of them. But now the hard part is coming to link these little shits And from where, this is the most problematic area. We zoom in actually to show you exactly what I mean. Okay, so you see here are 3 pins, 1, 2, 3. This is negative, the last pin is negative. You can see the blue mark there and there, you see on all of them. And the top ones are positive. You can see the red mark there and there. And in the middle here, so straight in the middle, I have to connect this clock, 100 hertz clock line, common to everything. So these 3 pins will be shorted together pretty much, will be on a single line, and then connecting that line to this other bigger line that I'm having there. So that's a very big challenge. Let me show you here as well. Yeah, you can see already. You see this long brown line that is going to all of them, back to here and then to here and to that other ones. I should have put that long brown wire to these gates as well, because they are. I will in the future. I will correct it. Yeah. Shit. Now is the hard part. Another very interesting point, is that all these metal wires, and especially those wires that I put there for the power, for the positive rails and negative rails, they strengthen the cardboard. I'm not sure if I showed how flimsy it was, but the cardboard is very thin, and it was bending a little bit like this. If I will very slightly force it like that, it was bending. But now I can feel it's a bit more strong. I don't want to stress it, because those weldings can crack, and I will have to somehow to secure very well this board somehow, to make it bend free. I have no idea how I will make that bend free, but solution. I will think of something. Probably in the very end I will glue all this board, all the sandwich of cardboards that I'm having here. I will glue it to a piece of sheet of metal, only for the strengthening purpose, not to bend, to be sure that it will not bend. It will be very heavy, but doesn't matter. So right now I have 2 cardboards there, you see, sandwiched together, and in between them is the power lines, and this is another line. And these little wires here, that will come from those middle pins. And probably I'll add another board on top for protection first of all, and probably I'll have to put some, I'm not sure, to add some other wires to these pins, probably the outputs, who knows, or the other inputs. I will see. But so far this is the progress, and it is crazy, quite hard. Oh, these were hard, but these little guys here are extra hard, and I'm not sure if I will make it with the tools that I have. My tip of the soldering iron is not that sharp as I wanted it to be that small on that pin. It's a bit big, but it's big, but good enough. It's somewhere in the limit. But I wished I had a little bit more finer tip, more narrow. Yeah, this is the progress so far. Thank you very much, and see you later. All right, so far so good. I made 3 connections there, and there. You see this very tiny wire, very tiny. And it is uninsulated copper wire. I didn't use all of this. I prepared them, but they have isolation on them. I have to desisolate them, and it's not. I have to desisolate them with my knife, and it's not a pretty job. The wire is very thin, but it's way more better to use enameled protected wire like those than bare wire that is contacting everything, like I'm using here. I am risking big time. Remember that underneath or between these 2 boards, I have the power wires, and I'm checking all the time when I'm making a connection here. I'm checking if it's shorting with the power wires, because I know for sure these wires here are intersecting. I have a mess there, and I don't know their exact position. So let me show you these first two. Let's see if it's making clear. Okay, it did. So this is the wire. So I know it's not showing very well, but the wire is this. You see it up, it's going up, and here as well is this, and here as well. But I didn't solder it on the other side. So these are the wires fixed in the middle, and I did bridged a couple of times actually these 2 pins, fortunately, and not those. Only these top pins, I bridged them here on this last one, but I managed to unbridge them. And here, what I did here, that's why I'm filming this, to show you. I'm not sure how well it's showing, but the wire is not coming like this straight. I actually wind it 1 time, and this one as well. You see it here is winding like that, and it's going somewhere there. And this one I will wind it 1 time, just to be sure it will not snap. I have the certitude that this wire will not snap from the solder itself. If the solder will crack somewhere there, because this is a very fine wire, it will still hold. I know for sure it will still hold. This is until here. This link that I made is until here. So I made these links. You see these links to actually help with the wire here. I don't want too much finer wire floating around, moving around here, especially it's bare wire like that, unprotected, because I will have to add another layer of wiring, probably. And being this thick is offering a little bit of strengthening and securing a little bit the circuit, pretty much the wiring. So yeah, holy fucking shit, this is a challenge, a big challenge, but we are getting there. I hope. Another interesting point is that I wouldn't have started this project if I didn't know it will work, if I was uncertain it will work. So I started this project with the idea that it will work, because I tested it in Proteo Simulator and it worked there. I made some tests on a breadboard, and all these tests show me that it is working with the LCD that I have there, and that's why I jumped to this more elaborate, more complicated, and challenging, very very challenging board, and that's with this in mind I'm building everything. So yeah, this is it for this part. All right, unbelievable! I managed to link every signal wire, and I can show it there. You see, there, and there, and yeah, you can see the reddish enameled wire. This is the only enameled wire that I put there. The rest are bare without enamel on them. They are directly copper. But this one somewhere inside on this hole or this hole, in both of the holes, it gave me a short circuit to negative rail. And here it is. It is very very small. From this, you see, this middle pin to each little wire. You see how everything is linked. And also here is like a, yeah, it's raining outside, by the way, right now. Oh, and I check every time I made a connection, one link like this. I check it with my multimeter here, from negative to one rail, common rail, and from positive to one common rail, signal rail, because they are all common here. They are all linked together. And yeah, unbelievable. It was hard, and you must have a lot of patience. And I also got some bridges of solder, and I kind of burnt out the paper a little bit there and there. And it's looking a little bit ugly right now, a little bit burned, but yeah, so far so good. I am quite happy. Unfortunately, I cannot test it. That's the biggest issue I have when building such a complex circuit. I cannot test it until I will actually mount the display. Probably there are methods of testing, but I don't know them. So your guess is as good as mine. So I will build this blindly without testing, and at the very end I will show if it will work or not. I hope I didn't make any mistakes in the design and in the links that I'm adding here, because if I'm making some kind of mistakes, I'm screwed. It's a ton of work, and it's kind of complex. It's not that complex, but it is complex. All right, so far so good. This is the update for all the links or the signal. I actually write it here. LCD signal clock at 100 hertz is this entire line that is common for everything. All right. So I just made these little holes. Well, they were there, but I pushed them through this other cardboard as well, and you can see them here. You see them, the second line of holes here. Those are the common 100 hertz, and they are linked already, but these are, you see, on here as well. And I had to actually fight between the wires that are underneath. So the power wires, positive, negative. I have no idea what I touched when I was inserting the needle to make the hole. But for sure, on some occasions, on many occasions actually, on many holes, I feel like I had to bend it another angle to actually be able to poke through this side. And also these lines are touching 100%, especially there. I have no. I put another hole there, and I'm actually making between this, but it's still touching it. Unbelievable! And as you can see there in my diagram here, this middle B, the B pin, is the common 100 hertz that I already linked, but the A is the other input, and these are the holes for A. And you can see the red line crossing for the positive rail, very close to it, and I made a hole directly here next to the pin on the top. So yeah, it's crazy. What I want to say, if this will actually work, it will be a miracle. It will be a miracle without any errors, and actually work. This single gate chips, they are helping with the space, yes, but they are terror on wiring them as I'm making them. Of course, if you are making a cool expensive board with all the trackings layout, not like I'm doing it here, that will be probably more easier to mount them. But in my case, how I'm mounting them, it's terror. Terror on paper, on cardboard. So yeah, shit, I will have to, like I said, it will be a miracle if this will work. Holy fucking shit. And then I will have to drag the outputs, but it's an experience with this, and that's why I started making it. I hope everything will be okay. I really wish. I test everything, like I said, with my multimeter, and everything checks out. Okay, it's looking fine. We will see from now on how fine it will be. Very, very. Also, the board is getting thicker. This cardboard, this entire board is getting thicker in the middle, but thinner on the margin. So it's like a loop like that. On the top is bent like this, and on the bottom is bent like this, and is like a pillow. You know, is the shape of an eye, of a loop. You know, of a piece of glass like that, like an eye, you know, and like a pillow. And this pillow is not good because it's balancing in the middle and in the corners and in the sides is trembling. I'm not sure how I will manage to make it. It's because of this wiring. That's why it's having this is starting to get this weird shape. Oh shit! All right, so this is a piece of cardboard that I prepared. So here I didn't took in account. Or very serious, the links from the input of the 4033 to the outputs, all these outputs, but I will have to link a wire that will go to this input or this input. So to the 4 inputs of the 4030 chip, or the one single remained, the one single input remained on this smaller guys here. I'm not sure how well is this showing here. That is A and B is connected all the way. So from the A, from here and from there. So from this A point here, this is the input that this device is expecting, and this is the output that this device is creating, pretty much. And I have to make a link, a wire linking to those pins there. And I didn't think about it in 3D. I let it to be solved in reality. And this is me trying to solve this issue, this problem. So these are the 100 hertz, it says there, 100 hertz signal clock. And I put a piece of paper here, I glue it, and then I took it out, and I created this stepping up, like it's like a border, you know, this cardboards. I'm having here 2 sets of cardboards to heighten it a little bit, to make everything more height. And I will glue this cardboard from a chocolate. I will glue it by these longer pads, and not actually pressing on these very fragile connections that I'm having there, but in the same time preserving the flatness to be flat, you know. And I'm shooting 2 rabbits in the same. It's not perfectly flat right now. I should have added more height, and a bit more height with this cardboard, but as it is right now, it still has 1 or 2 guys sticking up too high from these soldering points. But it is good enough, and I will have pretty much like a gap here. You can actually see through it, and it's about 1 millimeter probably, or maybe 2 millimeter. Yeah, another thing is that I've added this cardboard. I glue it here, actually, it's glued here. And then on top of it, these little pads on top of this larger one. And this larger one, I put the numbering, the correct numbering, and I will have to drag. This actually signifies not the output, because I did numbered or marked the output as A, B, C, D, A, F, and G. It's actually the input. So this input from here and from there will go into its respective designator. It's a bit confusing, but it's about the A gate, pretty much. This is the output of the A gate, that the output of it will go to the LCD, and the input is still A gate and B gate and F gate and G gate, pretty much. And this is the C gate, A and D. This is A, D, and C. So pretty much that's the idea. So these are all inputs for this chip, for all these chips, and they will be connected from this. I will put some holes, and I will drag the wires underneath. After I will glue this cardboard here, after I will glue it here, I will get the wires through the holes. I will make the holes here, and I will drag the wire, and I will get the wire out until the margin of this cardboard, pretty much, a little bit out, and I will stick it, probably from this side here. I will stick it, and the wire will be ready to be connected, and also prepared to be connected to this output chips that I'm having here. So I didn't think of it, but this is my plan. This is how I plan to do it, and I think it is a solution, especially for these little motherfuckers that are very, very hard to deal with, because they are so many and they are quite close together. And spacing, the space that I'm having here is the bare minimum. It's a very good spacing what I'm having right now, actually. Less than the space that I'm having right now, it would have been a very big problem, almost impossible to work with. The space that I'm having right now to work inside this chip, in the middle of these two, and in the side of this guy, is workable. I can work with this in the middle, and this is more easy to work. This is the peripheric ones are more easy to work. But other than that, it's quite hard to work on especially on these little guys, because those pins are super fragile, super fragile. Those pins, and I will have to secure the wire, to glue it, to firmly secure it, not to move around. That's my biggest concern, because after I will drag this input wire to these holes here and secure it, I will have to deal with the outputs. And the outputs, I will most probably do it exactly as I did it in the 3D. Here on this side, I will make the wiring exactly, well, not exactly, but pretty close to this drawing that I'm having here. So that's the plan. This is how I will proceed. And this board was exceptional hard, and with very interesting problems to solve, especially by these little guys. If it was only these larger chips, it was not that a problem. I will not have been complaining so much. But because of these little guys, holy fucking shit, they are posing a ton of problems. And yeah, not that good to work with them, unfortunately. I mean, you can work, but it's much more harder to work with them than with these larger ones. But they are saving some space, so that's the trade-off. Work hard and get some smaller size, pretty much. That's the idea. All right, that's it for this part, and see you later. So if you didn't figure it out so far, this is called the driver board. And I punched with my needle all the input connections, and for these little guys as well, in those two. This not on the top, but yeah, and also this bottom line here, the bottom, the final connections, that the ongoing connections that will go outside to the other board. And yeah, this is the driver board, pretty funky. If I was having instead of these little guys, these little gates, instead of them also having and putting these larger ones, the board was considerably longer, like this long, probably three, but seven of them, I believe. Yeah, but this is what I wanted to show you, that I punched, that I made the holes, and you see, for everything. From this other side, actually, I punched those, and here from this side, and I have the holes. Hey, now I have to drag the wires. We will see. I will have to do it this way in these steps that I'm doing it already, because the outputs will be the last to add, because I will have to put this very long, very high component. Is very high, and this very high component is literally impeding me to work on these little guys here. I cannot work on them or any of them while those big fences are in place. So that's why the order that I'm doing things, and the last will be this outputs to add. Who knows? Who knew? Who knew? All right, experience. This is called experience. I hope this driver board will actually work without problems, without errors. Holy shit. Wish me good luck from the future there when you are looking now in the past when I'm building it. Do you like my logic? Q12 logic. All right. All right. I think it's interesting for anyone to see how I'm making the links. I already made these links here for 7 gates, 4 here and 3 these little ones here. And now I only made one link, the A gate, and now I'm on the B gate, which is this gate from this larger chip. But the next gate will be the C, D, A, F, and G. And I will do only the B gate, which is the chip gate. Very convenient, very easy to do it. And next I will do the C gate, which is this motherfucker. And yeah, it worked for these guys. I already made the test. It was a little bit funky, but it did work. I have to pay extra mega attention there when I will link it. So let's do it. I only measured the wire, and by measuring it, I inserted it through this hole here. You see here? I inserted it through this hole. I bent it a little bit. I hold it with my finger, and I elongated the wire until it reached this long, and I cut it, and that's it. This is it. And then I took it out from that hole. And it is having isolation, and I have to desisolate its ends. And because this will be linked to this larger chip with large pins, it's kind of easier to leave a larger side there. But when I will get to that little fucker, this I will have to be careful with the desisolation, not to desisolate too much, because this is the entire point of using these wires, not to contact when it's getting through that hole, not to contact with something else that is inside. I don't know what is inside. It might be some power rails, some naked rails that are prone to contact and to short circuit. So that's the point. That's why I'm using this protected wire from making shorts exactly when I'm inserting it to that hole. And the rest of the way it doesn't matter. I'm checking it, it's good. And the other end. I'm usually working at the end of the table, in the margin of my table, and not having to keep my hand like this. This is very uncomfortable for me to work like this. But I'm showing the process, what I'm doing and how I'm doing it, But usually I'm keeping my hand in air like this, and this is supported on the table, on the margin of the table, and there I'm scratching a little bit more comfortable for this hand that I'm holding the wire. And I'm checking if this is good enough. And right. Okay. So this is it. I'm pushing it, but on the other side I'm bending it, you see? I'm holding my finger directly on the bending, and if I'm pushing it a little bit more, I'm bending it a bit more on the end. I'm usually doing this while the board is down, like this. And now I drag it like that. This pin of the leg of the chip doesn't have any kind of solder. I didn't prepare it, but the solder is catching very easy on it. And this is it, pretty much. Okay, this is one wire. This was the easy wire. And okay, and now this guy here. And I know for sure. I tried to make a hole here. You can see it. This little hole here. I tried to make it, and I got into some metal there. and I know for sure I have uninsulated, very conductive wires there. So that's a problem, very big problem there. Also here as well is literally the wire is between these 2 points there. Here is no problem, and I believe here it was also a problem as well. So here I will have to enlarge this hole to prepare it right now, and it is at an angle. It's like this, a little bit not perfectly straight, because I have to kind of, that wire is in the way a little bit. I'm touching it. I know for sure I'm touching it. And now to prepare the actual wire for this. All right, so now let's cut the wire. Actually, let's measure the wire first and then cut it. By the way, this is the only cutter I buy from China, and I have it for about 8 years or something, and it's still good. I took care of it. Only the tip of the cutter is is like this, exactly like this, like between my fingers here and here is rounded, a little bit rounded. Very exactly on the tip. I remember when it was new, brand new, it was cutting on the tip as well. But yeah, well, I did use that tip quite a lot probably. And also, as you can see, I file it like this. It was even sharper here, but it broke. So I polished it and I made it new tip like that, new, you know, and it's quite good. It's quite good. It's good enough, right? My cutter that I have it for a very long time. So let's measure this wire here. So it needs to come through that hole. Actually, I will have to insert on that. I can feel I'm getting obstructed. I cannot easily thread it through this hole. I'm now it got there. So I will keep like that. I hope it will not turn until somewhere there. And that's it. That's what I wanted. This is how I'm measuring the wire. I'm actually inserted in the hole, dragging it to the respective pin approximately, and then cut it at the end. And now this is very problematic because it must have a tiny little bit of desisolation here in the very end when it's making the contact with that pin. And after that, desisolation must be isolated very good here. And these wires are very well isolated. I really like them. But now something like that, a tiny bit of desisolation. My knife, the very tip of the knife is not sharp enough. So I must go here. So my tip on the blade is a bit more sharp here than on the very tip. I need the tip, and it's not good. I can feel that it's better on the longer side than on the tip of the knife. So that's the point that will connect to the pin on that gate. Pretty much is it. Yeah, it's good enough. So it's okay. And now here I can isolate as long as I want because this is empty. I need it to be on here. We have plenty of soliding on that side. These cupboards, they really got very strong. Now when I'm getting inside those connections, those wires, metal wires, steel wires, and they got quite strong on the board. I'm not sure if you remember how thin it was at the very beginning when I mounted my good. These guys, this is good. Yeah, it looks like it is good enough. Right. Alright, okay, this is one. And this is the important can, which is small. But enough, it's small enough to make the perfect connection that I needed there. And I know you cannot see it probably well enough, but it is desolated and now it's prepared there. It's a little bit whiter at the very end. And now let's mount it. Let's mount the wire. There it is, very easy. Like that. You see how I'm holding it? And now I will bend it. I have to put it here, and now drag it. It did rotate a little bit, like that. Okay. Yeah, probably my hands are on the way of the screen, but I cannot do anything about it because I need to make this correct here. So probably I'll have to zoom like this, and this over here. It's here. Okay, so it's this guy here. And I hope you can see the wire, like that. Good. Okay. So this is the wire. You see it? If I'm moving the board a little bit, you see it? When I'm moving the wire, it's moving there, and that's what I have to solder. That little fucker, and a little tiny bit, like I'm touching it. Like, do you see what I meant? The tip of the solder to be able to reach inside. That's why I leave such a big space between them. It looks like it is. Yeah, it is. And yeah, if I'm dragging the wire, you can see the wire that is moving there. You see it? Probably a little tiny bit. And that's it. This is it. And now, here it is. Now I'm looking there. Yeah, is it? It is soldered. Very, very good. Okay, let me zoom out. And now I will drag it to this C port there. Right. It's a bit too long. Yeah, that's okay. It's fine. Right. And usually for some guys I desolder it and resolder it again but I will not do it right now because it's good enough. And this is it. This is how I'm soldering a very, very tiny pin of the chip with that tiny wire. It must be almost perfect, like that, you know, like that. Diameter on diameter. The diameter of the pin with the diameter of the wire. Pretty much this is what I'm doing there. This is how I'm soldering them. And mostly the tip of the wire. It's crazy. It's crazy. But so far so good. I mean, I made all these 3, and with that one 4, it's good enough, you know. Okay, see you at the end when I will finish everything, hopefully. And on the next stage. Fucking hell. This was intense. This was very intense, hard work. I managed to put all the wires, all the inputs. And here it is on the back, how it's looking. And yeah, the driver board, fucking hell, all these inputs. And I was thinking of this. I have no idea how I will link from these points forward, because here it will be the other chips. And it will be some of them will be very, very short links, probably. And some of them will be a bit more longer. They will jump to the pins of the other chips, probably. Yeah, the only thing that I have left right now are the outputs, exactly where the letters are. You see that letter A? Let me actually point it. Wait with this. So this is output, and 2 inputs. You see, and these 2 inputs here on the other side, 2 inputs, 2 outputs, and 2 inputs. And the same goes for everything, and also for these little fuckers. And this was intense and crazy hard. It was crazy hard because of these little gates. They've added a ton of difficulty, a new layer of difficulty, pretty much. It was a challenge. I put my eyes on these gates for a long time, actually, and this is my first time using them on a breadboard, on a circuit, and it's crazy hard. It's a bit too hard. I better, yeah, well, for using them like this, multiple of them. If you have to use 1 or 2, yeah, it's fine. But if you have to use like 12, like I'm having here, not so fun. Not so fun. Yeah, very interesting. It's an interesting experience. I hope I learned something. What to use and what not to use. And I'm still indecisive of these gates, if to use them in the future or not. I'm really undecided. Because they are too tiny, too fragile, everything, and I have to really be careful. If this board will work, it will be a miracle. All right, here it is, the outputs, these wires here that are visible here, and you can clearly see them. These red wires, enameled wires. These are the outputs, and this is the final layer of wires. As you can see, I finished these inputs here, actually specified there, their inputs. I managed to put a little bit of paper there, and with my favorite shoe. You see, it's a shoe there, glue, and that's, you know, it's saying that is a glue for shoe. It's made by Romanians, and it's a national glue. I believe only here in Romania is made like this, but probably you can find it anywhere else. So it's very rubbery. When it's hardening, is like a very hard rubber. So it's not like a cement or like a brick hard, you know, like a dust that is making dust if you scratch it. It's quite rubbery, and if you try to unstick it, you have to put a lot of effort, because it is getting into the pores of the material, whatever material it is, even plastic, is trying to get on each pore, each molecule there. It's very good, very sticky. So I put this little piece of paper with this glue to hold them down, because they were staying up like this, you know, and gluing them down like that is much more better right now. They were springing, they were like little springs. Of course, I made some mistakes. I calculated a little bit longer this one, but and probably those one, but yeah, well, or too short this guy here, but it's good enough. I mean, I can reach the pins. These pins I have to solder to these wires, and the pins are ending at these dots that you are seeing there. You see these dots here are the pin ending, and you can see a very dim line. You see here is a line for the ending of the pins, but here is another line. It's barely visible because, well, I handle it. I put my hands and it erased. So from here to here is the pin, and from here to here is this plastic block. So that's the layout, how it is. And I mean, even if I'm having this very short wire here, it's still I still have to bend it to link it to the pin. The same goes for the others. I will bend them to their respective pins, probably. I have no idea. Probably I will shorten them and re-scratch them. I hope not. Take them out and re-scratch and reshape it. I hope not. But yeah, that's the thing that I did so far. I made only half of the board, pretty much. Only these 2 chips, but none of these little guys yet. I will make first this bigger, the big chips wiring, and then at the last point I will make the small ones, because I will use a separate wire, different wire. So right now I'm using this 0.25mm wire. This is the wire that I'm using, that you're seeing there. But for those small ones that I'm having here, also I used this 0.17mm, and most probably I will use the same for their outputs as well. So it will be a different wiring for different chips, pretty much. This stronger wire, I have where to solder it there. But if it's too strong, the wire it will move out the chip if it's too little. So that's why I'm using a smaller wire to be the wire to bend, not to get to get out from its place the chip that is so fragile there. So that's the progress so far. I hope you like it, and see you later when I will hopefully finish it. All right. The LCD driver. So I managed to complete all the larger chips here, outputs, and here on the bottom as well. And next is this little guys and those, and it is finished, the LCD driver. Let's hope it will work and not give me any kind of errors or troubles. I made it correctly, everything. We will see in the end how it will actually behave. I don't know what to think. I don't know what to think. I really don't like this kind of projects too complicated, because I cannot test them while I'm working on them. I cannot test well, I can test it, but it's a bit too hard to test it, and for each gate it's way a bit too hard. Theoretically it's not that complicated, but there are too many gates here, and yeah. What I mean by testing is testing it in circuit, the circuit that I'm building for. That's what I'm saying, and I really like easier boards to make, and not this complicated like this one is, because actually I can test them in circuit and see exactly the behavior if it's a problem. So far for this board, it's only this gated chips and the wiring, and that's it. That's all there is to this board. But the wiring was very, very complicated to build. The entire project it me a couple of days, probably 1 week, to build it like you're seeing right now. And it's not finished yet. I have to add those as well. Yeah. See you later. All right. A little very small update. I put these wires for this gates, 3 gates, the last 3 wires per each gate, and these are the outputs. This wire, and this wire here. I only put here on the top, and next I will have to add these guys here on the bottom. Yes, that is a good thing to film while I'm soldering this last wire here on the last gate, and all of the gates are connected to the outputs. Their outputs are connected, are wired, and the driver board is 99% finished right now. So first of all, I will have to desolder, to desisolate the wire. I'm usually doing it on the margin of there is some interesting story here. Right, so I have, this is how I did everything that you are seeing here, exactly like this. I'm desolating with this knife, this manually mode, like you are seeing here, you see, and I'm scratching the enamel, the isolation from the wire, little by little, with patience. But this kind of work is kind of stressing. It's not a nice work to do. It is stressing. Wiring, making the wires, mounting the components is not a problem, but wiring, it is very, very time consuming, extremely time consuming, and probably that's why nobody wants to do it like I'm doing it. But it is possible. What I'm showing here, it is a possibility. It is a way of doing electronics on cardboard with wires, and the way I'm doing it. And this is the way. This is my way. So this is it. I desoldered the ends of this wire. Now I'm fluxing it. Actually, this is a resin from trees. And from special trees, not from any kind of tree. The trees that are growing in the mountains. You scratch the resin from the tree, and you put it there and use it like you're seeing me here. I've always soldered the, let me show you. So if this is the component, the SMD, that I'm having there, with 2 pins this time, the wire I'm putting it like this, along. So when I'm putting the solder, I'm soldering along the pin, the longer side of the pin pretty much. And in my opinion, it is better. So that's why you are seeing me right now doing it like this, but then I will bend it. This is how I did it for everything. I only have to touch it a little bit. Let me check if this pin is having solder on it, first of all. And to touch it with a tiny bit of solder, there. And now, to add this wire to it, I only have to get near it, and to heat it up a tiny bit, and that's it. It's a very fragile, and now, very easy to melt than to put it there. Quite easy. And now I have to bend it into my desired position, or shape. And this is how I did everything that you're seeing here. Exactly how I'm showing you right now. I'm not making shortcuts right now. I'm showing you exactly the way I did it. This is the way. Alright, so I'm bending it, following the drawing that I'm having there, and that's it. This is it. And now I have finished the entire board, driver board for this fucking LCD. And holy fucking shit. This was very, very, very hard. Quite hard. Very hard work. And with patience, and I cannot test. That's the biggest problem that I have. I cannot test it while I'm working on it. Usually when I'm designing something, when I'm building something, I'm making some steps, and I'm testing very quickly to see if everything is good. With the general circuit, not the gates by themselves. Like I have an option, but nah. So next, immediately after this, I will have to mount this guy here. And this is it. This is the LCD and its driver made from XOR gates. Now I have to glue it here, to solder it here. And for each respective pins, to bend probably the wire. I have no idea. This is the first time I'm doing something like this. Yeah, they are aligned pretty much. So yes, the final look from this finished cardboard driver board. For I will have to put some glue probably, as I did here and here, just to be sure. I will probably show how I'm putting the glue. Okay. So I'm having some piece of paper, and yeah, It's good enough. I'm measuring what I need to, how much I need to add. Something like that. For that, and here I can add it all. Two of them. To link these two guys as well. Let's see. I can put it like this. Yeah, probably. Maybe. It's not that I'm cheap with the paper, but I really don't need more than what I just cut there. And this is how I'm putting the glue. Okay, I'll put it here. Okay. Like that. And I'm wiping my tool from this piece of paper. And it's already very sticky. I also want to leave these marks here to be visible. And I also want to leave the wire visible through the paper. So I'm pressing and I'm forming the paper around the wire pretty much. You see? And here as well. Yeah, and I'm pressing and shaping a little bit like a channel. Okay. Alright. So now this is very good there. Here I put it exactly on the markers and I cannot see the markers very well. Yeah, it's good. And the next little piece of paper as well. Just to be sure there. Alright. The same procedure. I want them to be glued, these wires. I want them to swim in glue. You know, to be borrowed in glue. This is getting out the excess from my knife on this tiny little bit of paper. Okay. And this shit up. Let's shit it up. Okay. A little bit of fresh glue here. And also quite thick. Okay, now it's good. Now this is very good what I have here. And I hope it's long enough. Okay. I will clean it. This is not some special paper, it's just normal paper. There's not something special about it. And don't be afraid to experiment. Yeah, okay. Probably. I have no idea how this wire is going. Like that probably, yeah. Like that. And this one as well. This is called forming. I'm forming the paper. Excellent, excellentos. And this is it. This is a bit, I can clean it. I said I will put this little one as well. Here. Yeah, I took too little. Or maybe it's good enough. Like that. Okay. Maybe it's good enough. Okay, good enough. That's good. Alright, now I like it. What I don't like is that by adding these wires to everything, I kind of covered the markings, the letter markings on the cardboard as it was before. So now you can barely see what markings are for everything. But for a debugging purpose, if something will go shit, but it's good enough, I suppose. So this is it. This is how I'm gluing these little patches with a strong adhesive. And voila, this is it. This is the final driver board or the LCD. Thank you very much. See you later. I have this board now, and something like that. And this is looking very funky. And I will have to drag some wires from there to here. I believe a clock wire. It's only required the clock wire and positive and negative wires as well. I'll have to drag them. As I imagined I will put a wire, a red wire here, a blue wire or black wire here for the negative, and that's it for the positive and negative. And the clock signal from this arrangement that I am having here, probably from this pad as well, in the middle. That's the output or something, I believe it was. And from there, I believe it was on pin 40. Yeah, we will see. So only 3 wires from there to there. And from here, from this board, all these fucking wires to the next board. And also the positive and negative as well. Pretty much. Okay, see you next time. Alright, this is it. I assembled the LCD. It was quite easy. I had to bend each of those wires. And let me zoom in actually to actually see how everything is bent, on its head, all around. And solder to its respective pin. As you can see, everything is bended like that. And I put a red wire, a power wire, because I don't want to play too much with taking out and putting it in. It's quite sensitive. I don't want to fuck it up now at the very end. And yeah, I just prepared this red wire. There will be the black wire for the negative rail, and here on this pad it will be the signal, and that's it pretty much. And I looked on the on the board, on the original circuit, it appears that if I'm putting a positive signal on any of these inputs, of course I have to oscillate at 100 hertz from this oscillator. Of course I will have to put the link here, power it, and theoretically I can drive each segment if I'm putting to positive any of these inputs here. I did a quick look. I hope I'm right. I didn't stay and think about it, and I believe it is. I can test this LCD driver when I will hook it up to this module. I can test it a couple of lines here, inputs, to see if everything is running okay. It should run okay. We will see.